if I said the next number was 1, Gary's already told you, hasn't he? If you were listening. What's my next number? 2. Next number?
3, 5, 8.
And that is Fibonacci. And that's a recursive. Yeah, so this is a recursive sequence where the numbers preceding the term dictate what that term is. And we just add these surrounding. Yeah?
What's at the 0 and the 1?
0.
For a recursive sequence, there has to be a starting point somewhere because the next term relies on the previous terms.
But, so if you're saying, what, 0 plus 1 equals 1?
0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 1 is 8, 5 plus 8 is...
You should have done this with the alpha stuff, Gavin.
Did you already come at the beginning of this year? Because didn't we do Fibonacci?
Yeah,
we did.
I think we did.
I don't remember this.
Anyway,
I know you.
that's Fibonacci. That's a famous
I'm sure
recursive sequence.
Yeah.
Have you seen like the stuff with like all the spirals and
That's Fibonacci.
stuff?
Yeah.
How cool is that?
Maybe I pulled it out of your
I'm
assignment because it was in an assignment. It was in a Fibonacci was in an assignment.
Oh, we didn't do it.
Oh, we didn't do an assignment.
No, we did it in class.
Maybe you can
Anyway,
do it.
okay. So there's lots and lots of different recursive sequences that you can make up because it's any pattern to do with anything. So instead of adding the last two, and see that one, I can make it up to add the first two. How about I'm just going to start at 3 and go 5 and go, well, I want to do 2 times that one plus that one. So 2, 3 is 6, 6 and 5 is? Okay, so then it's 2 times that one. And then it's 2, yeah, so you can make up a recursive, that can be anything. So what we're going to do is we're going to keep it nice and simple and say that if it's a recursive sequence, so if I give you a sequence, a sequence, and you go, well that's not arithmetic, and you go, it's not geometric, what's your only other option? Well, it's not going to be Fibonacci, it will be a recursive sequence that is just in that pattern there. So I'm going to restrict the number of recursive sequence patterns we can have because there's an infinite number of them. Well, that's a little bit unfair to make you think about what that is in a time-constricted exam. It's going to be in that format there. So I'm going to say that is a recursive sequence because it's just because it is.
Because it's not geometric.
Because it's not geometric, and what am I doing? Add 6, and then so it's not geometric, it's not arithmetic, so it's got to be recursive. So the challenge is how we're going to find out what the sequence is.
But then how do you know if it's a recursive sequence or a recursive series?
I don't know. We will get to a recursive series after the sequence. Okay. So there would be a way that you can trial and error this, but that's not Maths C, is it? So I don't want you guessing and checking. I've got a particular form or a function here, a relationship between my terms. So how many unknowns do I have? 3. I'm going to say B and C are my unknowns, and this is like my y and my x if you think about it like a function.
It's a gradient function.
So, we've got more information than we need, don't we? So I'm just going to pick some values here. So I'm going to say term 1. Term 1 is 5 equals...
Yeah. Not the other way around.
Term 1, because this is term n plus 1, so that's term 2, isn't it?
Yeah.
So term 2 is 11 equals term 1, B times term 1 plus C. And then I'm going to say term 2, term 2, so I'm going to put my equals 23.
So just take.
What would you like to do there?
take the plus 5 and this equals.
So if I label that
Illumination.
equation 1, equation 2, I'm going to go 2 minus 1. I'm going to get in ahead. 11 minus 5. So all of a sudden these 2 equals 10 plus C. C is 1, so I've got my term 10 plus 1 equals 2 term n plus 1. And then you can go back and check it, and then you can you find the 1000th term?
Yeah.
So with a recursive sequence you can't, because all of your terms rely on the previous terms. Yeah. So it's quite complex to find the 1000th number or the 500th number, because you need all the numbers beforehand to work it out.
You could do it.
You can. And the series is the same thing. So to work out the first sum of them, to find the sum of them, you're going to go, well, don't I need to know the values of the sequence first? So there's an example in your textbook to show you how to do that in your calculator. You've got to think of your calculator as an Excel spreadsheet, and this is a way of incorporating technology into your exam. So you need to know this. If you think of an Excel spreadsheet, we can have put a term 1 in here and a term 2 in here, and you can put in there a formula for term 3. You can make that equal 2 times that plus 1. Yeah, and it can repopulate, and then you can copy and paste, all the way down to line 1000. Copy paste, and you can also then do auto sum in Excel, can't you? Yeah. So if you think about it like that, it's just that it's not auto sum and they're different keys in your calculator. But it's just an Excel spreadsheet type of facility in here that you just got to key it in. Yeah. So it'd be pretty easy. Follow your nose on the workbook textbook exercise question.